process the viral virus the same way the antigen presenting cell does, which is via the MHC class 1. So what you have here is this infected epithelial cells expressing the virus. I mean, peptide, viral peptide, MHC class 1. In the meantime, this antigen presenting cell, they need to do their job. Why? They need to activate T cells. So what they do, they sense the virus, pick the virus, process it via the exogenous pathway, express it via the MHC class 1, and go and activate naive T cells that will become infected cells. Where? In the lymphoid tissue. And what these naive T cells become, they become effector cells. They know what to look for because they've been introduced to what the virus look like, and they're going to start looking in the lung epithelial cells which cells have been infected. And the cells have been infected as the one that expressing the MHC class 1. And once it senses that, what it is going to do is going to kill the viral infected. Very ingenious system, no bystanding effect. It's really specific, okay? And the reason why I mentioned that viruses can be picked up by antigen-presenting cells, but also by the favorite target cells, is that every virus has or infect a particular cells, which we define as tropism. Hep B, Hep C infect the liver, lung epithelials, coronavirus infect respiratory epithelial cells, so and so on and so forth. So they have a tropism, meaning that they can infect only this particular cell type or tissue. Okay, and in order for this tissue to get cleared, you need activated T cells. So I hope you understand now the importance of having MHC class 1 on all cells as well as on antigen presenting cells. So let's see now how antigen presenting cells process extracellular microbe, meaning bacteria. Look, and everything comes back to where the microbe is processed. Under no circumstances, this is your bacteria, you will see the bacteria inside the cytosol, like you've seen in the case of viruses. They will always remain inside vesicles, and these vesicles will be exposed to lysozyme, which will degrade the microbe. And then this vesicle containing the bacterial peptide will fuse with other vesicles that contain MHC class 2 molecules, which are DP, DQ, DR. And when you have the right match, meaning the right peptide for the right MHC molecule, you're going to have assembly, formation of this complex that will move at the cell surface. And therefore, you have at the cell surface an MHC molecule class 2 expressing a bacterial peptide. And what this will mean that when you have a T cells, in this particular case, a CD4 T cells, you will see that there's a bacterial peptide coming from Staphylococcus aureus, and you know exactly what the CD4 positive T cells will do. And we'll see that in the next lecture, okay? So this is extremely important. So you can see that the location of your microbe determine whether it's being expressed by the MHC class 1, like in viruses being present in the cytosol, or in vesicles being presented in MHC class 2. And you can see that it's an ingenious system to make sure that we develop the right immune response against viruses or against extracellular microbes such as bacteria. So I'm not going to spend too much time on that. These are what they look like, the MHC class 1, MHC class 2. This is basically where the peptide is being presented. I'm not going to say that. And this area where the peptide is presented is the highly polymorphic protein residues. And I said that. So this is a broad specificity, meaning that although one MHC molecule can only present one peptide at a time, one single MHC molecule can present different peptide, okay? And this is just to maximize the presentation capability. And as you can see, this is extremely important. Our survival depends on what? On the ability of MHC molecule to present the peptide. If we fail to do that, then we fail to mount an immune response, and therefore you end up with a very, very serious life-threatening condition. Unless you're being treated, you're most likely going to die. And this is a point that I want to raise, but I'm going to make it more clearer in the next lecture, is that the MHC class 1 only present peptide to CD4 positive T cells, also known as T helper, okay? While MHC class 1 will always present to CD8 positive T cells, which later on you will see will become cytotoxic T cells. These are the T cells that will kill all the cancer cells that we've seen in the patient, or viral infected cells, okay? And just remember the rule of 8. 1 times 8 equals 8, 2 times 4 equals 8. So this is how you remember. If I ask you which MHC molecule present to CD8, you know it's class 1. Which MHC molecule present to CD4, it's 2, because 2 times 4 equals 8. Just a tip to remember. Okay, so these are the point. The host can deal with a variety of different microbes, and this is extremely important. These genetic polymorphisms guarantee that at the population level, we are not exterminated or extant because of one new virus or microbe or mutated one. And this is extremely important. And for the MHC molecule, the more diverse it is, the better for us. Because the more diverse, the more likely we'll be able to cover an array of different microbes, and the more likely we'll be able to mount an immune response. And as I said, this is a strength, but also a weakness, you will see later on. No individual have the same set of MHC molecules. So you're not wiped out by a single microbe, okay? This is what is happening. We have clear example. I've given the example of the adenovirus. You had one patient that had developed somewhat a serious cases, while the others just a mild. And you can see, what does it tell you? It can tell you that the susceptibility is quite different. We are not all equal when it comes to susceptibility to infection. Why? It's mostly because of our heterogeneity in the MHC molecule. And obviously, this is something, the wrong susceptibility to infection, that explain why some of us, depending on the MHC molecule we have, we're going to mount a weak immune response or a strong immune response. But in medicine, it's extremely difficult to explain to students this concept. And I've chosen to give you this example of two clinical cases, two patients, and just to illustrate the importance of having the right MHC molecule. I mean, having the right to mount. So this is your patient. First one is 27 years old, history of injection drug use. So as you see, breach of the innate barrier, in addition to if you use contaminated needles, Hep B, Hep C, HIV, and you name it, whatever. And he has started to develop opportunistic infection. These are infections you wouldn't see in an immunocompetent patient, individual, okay? So these are really diseases that you see appearing when your immune system is down. In fact, it is, because if you look at the CD4 T cells, these are really important, okay? Very important cells to orchestrate CD4. You see that it's below a threshold where you are required to start treating the patient. And you know that he's HIV positive because he has a clinical manifestation of all this opportunistic infection associated. And you can see that his viral load is skyrocketing. I mean, it's just, so showing that indeed the virus is replicating at an incredible speed, and he needs to be treated with this highly active antiretroviral therapies. This is extremely important. And because of that, patient now is a combination of three therapies that are able to make it. Look at now the patient number 2. And the patient number 2 is what? That she's his partner. And she's 25 years old, female. She tested positive for HIV. So we're not going to speculate on how she got the HIV, but there's two ways. I mean, I want you to think about it, but it's mostly obvious. Sexual, unprotected sex, that's the first one, or shared needle. That's but despite being HIV positive, look at the CD4 positive T cell count. It's still normal, and she's able to control the virus beautifully. Treatment 0. So you have, same virus, different subject, different clinical outcome. And we realized that patient who was among this patient we called elite controller or long-term non-progressor, because they are able to control the viral replication. And when they looked at the reason why, there's many reasons, but when they looked at the reason why, they found out that the MHC, the patient number 2, the female, had the MHC molecule. Remember, we're all born with a set of MHC that representing the viral peptide that were not mutated. Okay, they were presented peptide from the protein that the virus could not mutate. If you were to mutate this protein, it would affect its viral fitness. So the virus is not stupid. It's not going to kill himself. What he wants is to replicate. So if he wants to mutate things, he's going to mutate things that he doesn't need. And what they realized in this patient number 2 is they had the MHC molecule to present the peptide from the protein that the virus couldn't mutate. And if you cannot mutate this protein, then therefore, if you can still present it, you can still mount an immune response. And therefore explaining why this patient number 2 here is able to control the virus, because the MHC molecule are able to present the peptide. While in patient number 1, because the virus mutates, it can no longer, because remember, we're all born with a set of MHC molecule, okay? We can't change that. So if the protein we're supposed to present have been mutated, there's no way we can present the protein, because we have no way to change this MHC molecule. So that's why having the right MHC molecule sometimes can save you. Okay, so the other problem before we finish, remember, I just want to lie that we finished at 7, at almost 10, so we still have a little bit of time. So the MHC molecule, because they are unique, we are all different, then if there's a mismatch, because they're expressed on all tissue, the host will see that as foreign, and therefore, if there's a mismatch between the HLA molecule, between the donor and the recipient, then you're going to have a transplant rejection. In fact, this were the first work to show the importance of the MHC molecule, because they are so different. And the other thing, which is clinically important, we know that the HLA molecule are sometimes associated with autoimmune disease, and they are clinically used. You can do a matching just to make sure that, and we don't know the link. Why is, for example, ankylosing spondylitis patient associated with a high HLA-B27 haplotype? Why is that? Allele. Why is that? There's speculation, but I'm not good. So, but it's clinically useful. If you have a patient with ankylosing spondylitis, you do an HLA typing, you're going to see that most likely it's going to express HLA-B27, and it's going to be a support for your establishing the clinical diagnosis. Same for diabetes, but for all autoimmune disease, there's a component. The link, I don't know. Okay, here's the part that I wanted you to think about, and I hope that we're going to have the time to see. So, if I were to ask the gentleman in the room to tell me what women are looking for when they're looking for romance, a love story, or whatever, what are they looking in men? So we can do a poll. I don't know whether it's too late, but you have different one. You have one. We don't need to do a poll. If you want to write it down on the things, what do you think would be the best characteristic that women would be attracted to? Is that the brain? Is that sense of humor? Is that confidence? Is that charisma? Is that balance? Forget about good listener. I'm not aware of any man who is good listener. Go with the flow, presentable. So if I were to ask the men in the room what they think women would be attracted to, is there any answer?
I can't do a poll on that one. There's too many choices.
No, you can't. But I at least have the students see what they say. Just a couple of students. We're not going to, because we have a short movie to see.
There is, somebody's asked, is there something to do with smelling your kind of immune system that's different to your pheromones or something are coming up?
There's some answer at least, so I can. Do you see any answer, Debbie?
Not well, that's what I'm saying. They're wondering if it's to do with pheromones.
Yeah, absolutely correct. Everything is about smelling, and the way women do that is incredible. It's just by smelling it, and the reason why, and you will see that, and many studies now have shown, and that the very studies that the type of MHC molecule women are usually attracted by a completely different set of MHC molecule, and the way they do it is just by smelling you. They can smell you, and by smelling you, they can actually sense that you have a complete set of MHC molecule. Why is it important? Why is it important for women to know that you have a completely different set of MHC molecule? It's because they want to ensure that their offspring, because of having a dissimilar MHC molecule, will be able to present a variety of different microbes than having similar MHC molecule. Remember, in MHC molecule, is the more diverse your MHC molecule are, the more likely your offspring will be good at handling different type of microbe. And this is basically, and the way we do that is just by smelling. And it is something that has been proven. And now there's many studies showing that this similarity in MHC molecule provide sustained relationship, great sexual satisfaction, great relation